Good evening, friends. How are you today? We'll, of course, get started. What did we discuss last class? Any idea? Type in the chat what we discussed in last class. Okay. In the last session, we discussed about functions, isn't it? We discussed about functions, isn't it? And we discussed about functions, and we discussed how functions can return a function or take input values. So there's not much to talk about in return, right? You can, other than that, in return, you can return any data type. You can return integer, float, string, or list, tuple, right? Anything you can discuss, anything you can return. You can even return multiple values, okay? You can return multiple values as well, okay? I think the last example which we did, we had 4 values, right? If I'm not wrong. Yeah, so this example we saw that we could even return 4 different values, okay? So you can return multiple values, okay? And you can return any type, right? You can have a list that can have 1,000 values. You can return that as well, okay? Okay. So that's in terms of return value. In terms of input values, okay, we have functions, okay, which can be classified into 4 types, okay, and that's what we will talk today. So today we'll talk about how to write functions and give input values to it, okay. Okay, so first we will start with function, okay, where it's called required positional arguments, okay. We have already seen this. Let's quickly revise what we saw earlier. So let's say I put a function here, okay, and I say add numbers or something. This is a function and I'm giving n1 comma n2, right? And I'm saying here, okay, print values of n1 and n2 are n1 comma n2, right? And then when I call this function, I have to pass 2 values here, okay? So this is an example of what we call as, okay, I'm going to put this here, function, or rather I would say example, right? It's an example of function that takes required positional arguments. Okay, so there are 2 keywords that we need to remember or that we need to understand here. First thing is called required. Okay, required means, okay, so it takes 2 values, isn't it? N1 and N2. And if I delete 6, let's say I don't give 6, I give only 5. And when I try to run this, okay, and when I try to run P1, okay, so it says add numbers is missing 1 required positional argument N2, right? The value that I gave 5 goes to N1, and there is no value that will go to N2. There is no value for N2, and this is what we call it as required positional. Okay, so it is required. It takes 2 values, so we have to pass 2 values, and values are passed in order. So N1 will take first value and N2 will take second value. N1 will take first value and N2 will take second value. Okay. Required because function definition has two values or parameters. So we must provide exactly two values. I cannot provide, okay, 3 or 1, right? Even 3 will throw error and 1 will also throw error, right? So exactly, okay, the exactly spelling is not right, you know it, right? So exactly two values, that's what we call required, okay? Positional because the order in which we must give, the order in which we must give will be matched from left to right. So that's why when I say n and n2, n1 will always take the first value, which is, let's say, 5, and n2 will be 49, right? Okay, so this is an example of function that takes required positional argument. Now there is a function type, okay, which we can give default values, okay, where it is not required to give all the values, okay. So I can create another function definition here, add numbers, and I can say n1 comma n2, right? And let me make it as 2 here, and let me copy and paste, and let me add few more. Let me add n3, n4, n5, values of n1, n2, n3, n4, and n5 are okay, are n1, n2, n3, n4, n5, isn't it? Now, so see here, this is an example where we have to provide all the 5 values. Okay, so if I try to call add numbers with 2 values, we get same problem, right? Like the last one. Okay, so what we can do is we'll say example of function with default values. So what I'm going to do, I'm going to define, okay, default values 3 to 3, 4 to n4, and 5 to n5. See, so in this case, I have defined default values for n3, n4, n5. That means if you do not provide value, if you do not provide any value to n3, n4, n5, okay, n3, n4, n5 will not take any value, but your n1 and n2 will take the value. So here n1 and n2 are required. So in below example, okay, n1 and n2 are required, whereas n3, n4, and n5, okay, has their default, or I would say, okay, whereas will take default values if not provided. If you provide it, okay, if you provide it, then it will take the provided value. And if you do not provide it, then it will take the default value. right? So if I call add numbers 2 here, and when I run it, N1, oops, what happened? Uh-oh, I'm sorry. I didn't see it. I'm sorry. This should be in the function definition. Okay, not here. Sorry. I did not see it. I was going with the flow. Okay, in this case, I meant. Okay, in the function definition, when you assign value 3, 4, and 5, and if you do not provide the value, it will take this assigned value. Now, if I pass, say, 21, then what will happen? N3 will take 21. N1, okay, let me write in different line. Add numbers, okay, 10, 20, so 30. In this case, okay, in line number 13, add numbers case, N1 will take 10, N2 will take 20, and 30 will be assigned to N3. So N3 is default, but still positional. Okay, still positional because N3 is at third position from left. So it will take third value from left. Okay, so N3 takes 30. So in this case, your N3 has 30. Okay, but your N4, N5, we are not passing. So N4, N5 will take value 5 only. But N3 will take 30 here. N3 will take 30 here. You see? Okay, so this is how we can provide values to default parameters also. Okay, default parameters, if you pass the value, okay, default parameters, if you pass the value, okay, then it will take the value that you pass. If we do not pass the value to the default parameter, if we do not pass the value, it will take the default value, which we give during function definition. So we say in definition, we say N3 equal to 3. You can give values to all the 5. I can say 5, 15, 25, 35, and 45. Okay, then you get the values here, right? 5, 15, 25, 35, 45. Okay, so if we do not provide the values, okay, it will take the default value. But if you provide the value to the function, it will take the value that we provide. In that case, the default values are ignored. Okay, so this is an example of your default parameter. Okay, now the third type is where position is also not important. Okay, one more thing that we have to learn here is, okay, if you have to give the default values, see, if you have all default values, then it's fine. But in this case, we have only 3 default values, right? And 2 required variable. So the required one has to be on the left side and non-required should be on the right side. I cannot say N5 is required. Okay, if N5 is required, it has to be added before default value. We should add it here. Okay, you cannot put a required variable after default one, because see, if you are making 5 as default one, then you have to pass values for N1, N2, N3, N4, right? Then only N5 can take the value. If you have to pass the values anyway for all these 4, then what's the point of making it default? There's no point of making it default, isn't it? That's why you have to put all the required one before and the default one, okay, at the end. Make sense? Okay. Now, Okay, so let's do one more example here. So, okay, so this is default one. Okay, third type. And in third type, I'm going to copy again the first one itself. Okay, so here I have N1, N2. Okay, and I call it add numbers 3. And here, okay, I say add numbers 3, N1 or N2 rather. N2 equal to 25 and N1 equal to 36. Okay. So see, in line number 11, N1, N2, these are your required arguments, right? Required arguments. Okay. But these are not positional because positional is determined by the calling function. Okay. So here I'm saying N2 equal to 25. Within the calling function here, I'm saying N2. This variable name and this variable name has to be same. So I'm saying N2 is 25 and N1 is 36. N2 is 25 and N1 is 36. Okay. That means you cannot, have N1 take the first value because I'm calling this N2 here. So N1 will take 36 and N2 will take 25. So this is how you can make non-positional. Okay, this is an example of non-positional. Okay, non-positional because the way we are giving here, we are saying that N1 and N2 need not be in same position. Need not be in same position. Make sense? Okay, so these are three types or the way you can declare a function. Let's take an example here. Okay, let's take an example. Okay, I'm going to create a kind of report. Okay, let me first define a function, and I'm saying def create a report, and it takes num1, num2, and t title. Okay. Now, I will make N1 and N2 both let's say 0 or -1. Let's say -1, and title I'll make it as this. Okay, so I'm going to if title, if len of title, okay, is equal to 0, or rather not equal to 0. Okay, let's do if it is not equal to 0, I'm going to say print 1 2 3 4 5 6 performing a report. Okay, and what I'll do here is okay, I am going to generate something like this. Okay, okay, and I'm going to say print score. Now, okay, Now see here, this is for headline. Okay, so a headline we want to be printed only if title is given. If title is not given, we don't want to print this, right? And performing report, and I want to say print title followed by title, something like this. Oops, sorry. Okay, so something like this. So what happens now? I'm going to create, or I'm going to call it, right? I'm going to call create report. Okay, and I don't pass anything. Okay, so what happens? Nothing is called, isn't it? Now I want to pass only title. Or quality score for today, something like this. Okay, just giving some title. So earlier when I did not pass, nothing happened, right? But now I'm passing title equal to, okay, so you see this is printed. Okay, now let's say we don't give this. Okay, let's make it very generic. So you saw that. Okay, this has happened. So you can create different logic, okay, based on something like this. Now if you don't provide title, this entire thing won't be printed. Okay, similarly I can check if n1, okay, greater than 0, then print score equal to okay, score equal to, let's say I put this one here. Okay, score equal to n1. So n1 is score, right? Similarly, I'll check if, okay, now here if n2 is greater than 0, you put n2, and this we call it as max score. Okay, and now we are giving only titles, so only title is getting printed. Correct? I can go and now I give n2. Now see here, since I am saying n2 equal to, okay, I don't have to give it in the same order. Now when you run it, you see max score 5 is printed. Okay, now if I say n1 equal to 3.8, so n1 will be printed 3.8. Okay, so see, we have just printed a report, and this is totally dependent upon the values that we provide. The more and more values we provide, the report is getting bigger and bigger. More and more columns are getting added to the report. So you can choose what to give and what not to give. The program will not throw error. Program will take what you give and perform the respective operation based on that. Any question? All good so far? Okay. Okay. So these are examples of your functions. Now the fourth type, okay, is called variable length argument. Is called variable length argument. So see, when you are passing or returning the value, you can return multiple values, right? And variables will be able to catch it. Okay, but let's say we don't know how many values we need to pass. Okay, sometimes user may not give any value. Sometimes user may give 5 values. Now in this case, if you see, okay, uh, in case of default, okay, even when we don't pass, some values are getting added by default. So variable exists. Okay, variable will exist, right? But we don't know what kind of values to pass, isn't it? Okay, and values, if as I said, right, if you do not give a value, the default values will be taken. But let's say in this case, if values are not provided, then it shouldn't be created. Okay, so in above case, even if you don't provide values there, isn't it? N1, N2 is there. It has some default values, -1, -2. Just that we are not publishing it, we are not printing it, but it is there, right? But in this case, we'll see how we can handle a variable length. Okay, so I'm going to say here def, okay, players. Okay, so I'll say players info or something like that. Let me call it. Okay, players info. First one, I'll say star names. Okay, I want to give a variable. Okay, but to make it as variable length argument, that means it's going to be a list of any size. It could be 0, empty list, or it could have 5 or 6 or 100 names added to it. That's fine. So I'm going to create names, and I want it to take to take default values from the input. Okay, so I say star names. Star names will become a list, and then okay, you can say double star information. So in this case, okay, your single star will make this variable a list. Okay, dictionary. Okay, so how it works is I can do the print, say value and type of names, say names, comma, type of names, right? Similarly, I can do value and type of, okay, information. So see here, in this case, okay, in this case, star and double star, both are added only when we are putting it in the function definition as parameters. But when you want to use the values, we do not give star double star. Here we are not saying star names. We are not saying double star information. It is done only when you are declaring it, nowhere else. Okay, nowhere else. Now, when you run it, how do we run it? We have to pass the value here, right? I'm going to say players info. Now I want to give multiple names. I want to give Sachin. I want to give Kohli. Okay, I want to give Kapil. Okay, let's say Lakshman. Okay, you can keep on giving any number of values, doesn't really matter, right? Now I'm going to say sports equal to cricket. So I'm giving sports. Now this is just like your variable name here, right? So that's why I did not put in a quotation. Sports is a variable name, so I'm not giving a quotation. Okay, I can say country equal to India, type equal to bat. Okay. Now, okay, let's see what happens. So value and type of names are Sachin, Kapil, Kohli, Lakshman, class tuple. It is read as not list, sorry, it's read as tuple. Tuple is immutable version of list, isn't it? And this is dictionary. Sports, cricket, country, type, it has read as a dictionary. Right? So you can pass any number of values here. Okay, I have passed 4 in names and 3 in information. Okay, but you can pass any number, even 0 is allowed. Even you can decide not to pass any value. Right? If you decide not to pass any value, the names will have 0 value, right? So you can pass in variable number of arguments. That means whatever you want to, how many ever variable that you want to, you can pass in the calling. Okay, in the definition, it is saved as a tuple and as a dictionary. So all the values that you give, like something equal to, okay, it will be read as a dictionary, and what you just give straight away values, that will be stored as a list. Yes, any question? So of course you can do it here, right? You can say, I'm just using some logic here. I can say if, okay, say home in information dot key. If home in, okay, then print home of the players is information of home. Okay. If you can decide. I'm just using it in some situation. Okay. If say home is there, sports, right? S capital or small one? Yeah. If sports in information, then sports they play, something like play is sports. So this is how you will access the values from a dictionary, isn't it? So sports they play is cricket, right? First one did not get played because we do not have home here, isn't it? So this is how you can handle variable length arguments. Okay. So in going forward, we will be using functions to do all our work. Okay. And now that we know functions, try to convert all programs that you write using functions only. Any question here, guys? All clear? Okay. Any question, guys? No? All good? Okay, great. So these are different types of functions. Okay, let's write a program to check. Okay, this is a good example. Let's try to do that. Write a function to check if a number is a prime or not. Then continue the function to generate, series of prime numbers. To generate series of prime numbers. Okay. What do we do? Tell me. Any suggestions? I'm going to move this. To our yesterday's is already updated on the site, so we don't need it. I'm going to delete it. I'll put it here, and now I'm back here. Okay, so write a function, okay, to check if a number is prime or not. So I'm going to say def is prime. Okay, it will take one value as input, let's say num, and then it's going to return either true or false. It's going to return either true or false, right? True if the number is prime, false if number is not prime. Isn't it? It should return either true or false. So I'm going to say, a flag. It's a variable, and I'm going to say variable is true. That means, the flag is true. Now, before I return the flag, I need to write the logic to check if that number is prime or not. So what are prime numbers? Prime numbers are the numbers that is divisible by 1 and itself. No other number other than 1 and itself can divide it perfectly. So of course, every number is divisible by 1 and itself, right? 1 into itself is 1. I'm sorry, itself. So the perfectly divisible, but no other number should divide it. Okay, 5 can't be divided by any other number other than 1 and 5. 2, 3, 4 can't divide it perfectly. Okay, 23 maybe. Yeah, 23 is again a prime. No other number can divide it perfectly. So what we do here is we check from when, from 2 to, okay, to that number. Okay, we have to check from 2 to that number, and we will divide if that number, okay, if that number is divisible, that's when we should stop, right? So let's say we take 6. We divide 6 by 2. It is perfectly divisible. That's when we should stop. We don't need to check, right? So we need to divide. So I'm going to say for I in range, and we'll say 2, okay, 2 comma, let's say n, into 2 comma n. So I want to divide for I in range, right? Sorry. So for I in range 2 comma n. So I want to generate values from 2 to n, 2, 3, 4, 5, so on. Okay. Oh, it's not n, it is num. Okay. So I want to go to the number that is provided. Now I need to divide that number. So if, okay, number divided by, or not divided by, modulo, right? I want to check the remainder. Remainder should be 0, therefore perfectly divisible. So if remainder divided by I is equal to 0, that means, it is not a prime number, correct or not? Right? If it's perfectly divisible by I, then it's not a prime. Otherwise, return true. Otherwise, it is a prime number. So you don't even have to check the flag. You can directly return false in case it is divisible, and in case it is not divisible from 2 to n minus 1, right? It is true. Simple. This is the logic to check if a number is prime or not. Okay. Now I need to use this function to generate series of prime numbers, isn't it? So I'm going to say for I, or rather I would say Let me take the input from the user. Okay, so start num equal to int of input from which number you want to generate prime. From which number you want to generate prime. Okay, and I'm going to say end num. Okay, up to which number, right? Okay, now I'm going to say from for j in range. Okay, start num, comma, end num plus one, right? We need to go one number more than, so that that number is covered, right? And I'm going to say if, okay, is prime, if is prime of j, then print j, right? That means if it returns true, then only you print it, otherwise don't print it. Done. And we want to print in same line, so I'm going to say end equal to, maybe use bracket, comma, or whatever. Simple, right? So now when I run it, it's going to ask me enter from which number you want to generate prime. I want to generate prime from, let's say, 1500. Okay, up to which number? 5000. So see, these are the numbers that are between 1500 and 5000. 1511, 1523, 1531, 1543, 1549, 1553. These are the words, or these are the numbers that are not divisible by any other number other than 1 in itself. Okay, so we have written a function to check if a number is prime or not, and we have used same function to generate our series of prime numbers. So providing an input, okay, as the starting and ending value, between start and end, how many or which all numbers are prime are getting displayed on the screen. Okay, simple, isn't it? Yeah, we just have to practice. Okay, so please do practice whatever we are doing in the class. I would say, please, when your class is done, please go through the video, go through the notes and practice. And if you have questions, put your questions there itself. Okay, and I'll answer it. Okay. Okay, great. So we'll do a couple of examples. Okay, there's one more concept which I want to do. And then when we meet, tomorrow we are not meeting, guys. Okay, we'll see you on Thursday. Tomorrow we will not meet. Thursday we'll see you. Thursday we will talk about modules. Okay, what modules is, how to use modules. And we have to do one more topic in list. So modules and list we'll do on Thursday. And Friday we will start our class on objects. Okay. Any questions so far? All good. I'm going to move this and save it here. Okay. There's one more concept here called as, what do you call? Okay. See, I forgot the name. It is called recursive functions. Okay. It's called recursive function. So we have seen function with return type, without return type. We have seen function which takes required positional argument. Okay, order has to be same and number of arguments that has to be there has to be same. Then we saw example of, then we have seen example of default values, where if we don't provide the value, it will take the default value. So you don't have to give all values, right? Then we have seen another example where we gave different position. So position is not important. So when you write equal to in the definition, it is of type second, default values. And when you write equal to in the calling, where I'm saying N1, N2, I can pass in different order. In that case, position is not important. Name becomes important. Then, okay, last type we discussed was variable length argument. You can write just one function to read multiple values. You can read the values as list and or. Okay, I'm saying and or, and you can list as well as dictionary. You can read it as just one, okay, list or rather tuple, sorry, not list, tuple or dictionary. Okay, so when you give single star name, it is reading as a tuple. When you give double star name, it should read it as a dictionary. Okay, but when you are using it, there's no difference between tuple and dictionary in the sense, okay, we don't say star or double star while using it. Star and double star is only at the time of declaration, so that user knows, okay, what I'm getting is this. Okay, what I'm getting is a tuple. What I'm getting is a dictionary. Okay, that's why we have to give it, okay, in the function definition. Okay, so those are the 4 types. Now we'll talk about recursive functions. What is recursive functions? Recursive functions are functions that calls itself. That calls itself. So if I create a function def myfunc, okay, def myfunc, and I give something here, print hello, and then I call myself myfunc. So I've written a function which is printing hello and calling itself. So what happens? It will go into infinite calling. Okay. So I always said that, if you remember what we discussed yesterday is, in this scenario, function definitions are not called, right? It's the main program which is called. In this case, the first line to be executed out of the 8 line of code, the first line that will be executed by the program is myfunc. Yes, everyone, that's the first line that will be called, because we discussed function definitions are not called automatically. Through calling, we have to call them. Okay, so the very first line that will be called in this program is line number 9, which we are calling myfunc. Now, okay, now when we call line number 9, it goes to line number 5. Then it goes to line number 6, prints hello. It goes to line number 7. After 7, it again goes to 5, 6, 7. Again 5, 6, 7, 5, 6, 7, 5, 6, 7, so on. And it becomes an infinite function call, not loop. Okay, this is not a loop here, right? It's a function calling. So it goes into infinite function call. Okay. So so we can run it and see. Let's run it and see first. So see, hello, 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 it printed, and after a certain step, it started giving error. What happened is 7, 6, 7. After 7, it should come to 9, isn't it? It's not coming back to 9. It's going back to 6, 5, 6, 7. So it has to store the information in the memory, right? It has to store the information in the memory. And after certain steps, you see that it's not going anywhere. So memory is full. Our program has stopped. Okay, saying that maximum recursion depth. So when program has built a maximum recursion depth, okay, around 993 is a maximum recursion. So if you cannot go beyond 993, otherwise, if that was not there, okay, in build, then our program would run and maybe our even complete RAM memory would have been full, right? So coming back to our discussion, we said that recursive function is function calling itself. It's a function which is calling itself. Okay, it's called recursive function. Okay. Now, is it useful? Of course, it is useful. That's why we're talking about this. but it cannot be used everywhere. Okay, it cannot be used in this case. If you want to print hello 1,000 times, you can use a for loop rather than this. But this is useful when the logic itself demands recursion. Okay, so there are few examples, okay, where we can use logic of recursion. So let's take this example here. You have 5 factorial, right? So what is 5 factorial? 5 factorial is nothing but your 5 into 4 factorial, correct? So let me build this factorial. So I'm going to say my factorial. Now my factorial will take a number like 5, isn't it? So I'm going to pass this. Oops, sorry. I'm going to pass number 5. Okay. And here I'm going to say n. I'm passing variable n. Great. Now 5 factorial is nothing but 5 into 4 factorial. So this factorial is a function to calculate factorial, but 5 is 4 factorial. So this is an example like 5 factorial, 5 into 4 factorial. So you are calling itself, isn't it? Perfect case to use recursion. So I'm saying 5 into 4 factorial. Let me not print hello because we don't need to print hello. We can simply say here, okay, we can say, okay, return what? I'm saying n, 5 into factorial. Factorial is what? My factorial, n minus 1. Yes, you understood, right? So I'm saying my factorial n, and this has to return n into my factorial of n minus 1. 5 factorial is 5 into 4 factorial. So 5 is 5 into 4 factorial. So I'm saying 5 into factorial gives the factorial, right? So 4 factorial. Now this will go on. We need to have one stopping condition. Okay, this is correct till, okay, so this is correct. Like 5 is 5, 5 factorial is 5 into 4 factorial. Your 4 factorial is, okay, 4 into 3 factorial. Okay, 3 factorial is 3 into 2 factorial. Okay, then you have 2 factorial, which is same as 2 into 1 factorial. Okay, and 1 factorial is 1 into 0 factorial, and you have to stop somewhere, right? You can't go for minus 1, 2, 3, 4. This is the perfect place to stop. What is the perfect place? When your n becomes 0. When your n becomes 0, okay, 0 factorial, you don't write 0 into minus 1 factorial. We don't write 0 factorial as 0 into minus 1. Your 0 factorial is 1. This is our ending line. 0 factorial is actually 1. You can look your maths notes. Okay, ending line for function. So when we say recursive function, that means, of course, 99% time you should do recursion, but one or two times, there has to be some condition where you break, where you don't do further recursion. Otherwise, it will get into infinite kind of recursion, which we do not want. So there has to be at least one. So whenever you are writing recursion, okay, function, when you're trying to implement recursion function on your own, okay, first thing that you have to ask is what is the stopping value? On what values this we must stop? We should not continue, right? Otherwise continue forever, correct? So we have to ask what is our stopping value beyond which if we should not perform recursion. So in this example, okay, 0 is the ending value. We should not go beyond 0. So when it is 0, when the n is 0, we don't do 0 into 1 factorial, minus 1 factorial. We rather do return 1. We give the value. Okay, if n equal to 1, return 1, finish. Now, when these are returning values, right? So we need to write a variable to catch, right? And then we print here. Very simple, very neat, clean code, right? 5 factorial is 120. You can do 9 factorial. That is 9 factorial is 3,62,000. Okay. So this is how we generate a recursive function. You guys are not asking any questions. Okay. All good? So again, today we have done a lot of things. Okay. Today we have done a lot of things. I want you to please practice. Okay. See, from now on, the level is going to get higher and higher, tougher and tougher, right? So use tomorrow's time to visit your previous videos, okay, and understand the concepts, okay. And today this is what I wanted to show. We'll stop here, okay. So every day what we're doing, we're taking one concept, we are learning what the concept, and we are doing example, okay, before ending the day, right? And concept also, it's not theory, right? We are practicing each concept. I want you to see the use, okay? I want you to see how the concepts are used. Okay, so we are doing small programs, then we are doing one mini program, isn't it? Okay, so yep, I think we will stop here. Any questions you have for me, please let me know. Okay, about any topic, not only today's topic, but any topic, so that you know so far that we have done. Okay, any topic, anything that you want to ask me. Okay, if not, we'll end it here. Okay, we'll see you day after on Thursday. Yes, everyone. So we have completed function. With this, we have completed function. Okay, we will be doing modules. Modules is like putting multiple functions together. Okay, so that's the topic we'll be doing when we meet in the next class. Okay, so enjoy, everyone. Take care. Have a good time. Enjoy. Bye, everyone. Take care. I'm going to upload these notes in next 10 to 15 minutes. Okay. In next 10 minutes, you'll find all of these at the same location. Bye, everyone. Take care.